Welcome. Let's talk about the map function, which is one of my favorites. Super simple, very useful, and you could make it yourself. So let's take a look at some. So if we go check this out, here's the method header. It takes 5 parameters, which is a bit of a pain, but once you get the hang of them, they're not so bad. Easiest way to get a feel for it is to look at an example. So let's check out the example. By the way, again, this is just the map page in the Arduino documents. Great thing to look up. Just look up map Arduino and you're good to go. So here's their sample code. So it makes an integer called val equal to the analog read of 0, which should probably be A0, but whatever. Anyway, and so then they convert that value into a different range. So they can use it in analog write, because as you remember, analog read will give you a number between 0 and 1023, but if you want to analog write something, you need a number between 0 and 255. And so it would be kind of nice, say val's hooked up to a potentiometer or something, if you could convert, like let's say the potentiometer is 75% of the way and you're getting an analog read of like 750-ish. It'd be nice if you could convert that to the 75% of the analog write range. So whatever that would be, like 190. So this is what map is great for. So map here is taking our value, which could be anywhere from 0 to 1023. And so here's our initial range. So first number is the number you want to convert, which I often use for analog read. Sometimes I just throw analog read straight in there. And then this is the lowest that value should get to. This is the highest value that should get to, which makes sense. Like if this is an analog read, the absolute minimum it could be is 0, and the absolute max it could be is 1023. So that's definitely the min and max. If you're using something like a photoresistor and it's got some different range, say it only ever goes from 200 to 900, you could put that in. If you go out of range here, you will end up going out of range in your destination, so keep that in mind. So anyway, so we've got our initial value, we're analog read, here's the lowest it could be, here's the highest it could be, and this is our destination range we want to put it into. So we want to switch that from having a range of 0 to 1023 to having a range of 0 to 255. And so this is great. We're taking a reading off some analog sensor and we're taking that value and converting it to something we can analog write with. Yeah, and that's a very common use of the map function. There's a couple little tricks you can do with it. Let's say I really wanted, if I've got a high value, I'd like to analog write a low value. And if I've got a low value, I want to analog write a high value. So if that were the case, we could do pretty much the same thing. We can reverse these. So this hopefully looks kind of funny to you. So we're mapping the analog read from our sensor of some form, which starts in this initial range. But we're saying that the low end of the destination range should be 255 and the high end should be 0. So this kind of maps it from 0 to 255, but in reverse. So if we have a full value, full 5 volts, 1023 to our pin A0, that'll be mapped to 0. And if we have 0 volts there, that'll be mapped to 255, like full on power. And any, like if we're 75% of the way here, if we're at like 750, we'd actually be around 75% of the way from 255 to 0. So something like 60. Anyway, so kind of cool. All right, so that is most of what you need to know about the map function. If your values do go outside of this initial range you've stated, you will end up outside of the destination range you stated. So careful with that if it's a problem. Another thing I want to show you just quick is here's the whole function. Notice not so bad. It's a header and one return statement. So it takes a little bit of looking, but if you check it out, this is just our output range, and this is just our input range, and then we got a little add our output min value at the end. So if we do our x minus an input minimum value, that says how far we are away from our starting point. And so if we divide it by this, that puts it as kind of like a percentage. Like if we're 50% of the way between in min and in max, this guy divided by this is 0.5. If this is 75% of the way, if x is 75% of the way to in max, this divided by this is 0.75. So if you think of this dividing by that, giving you a sort of like a percentage as a decimal, and then if we multiply by our output range, let's say it's between 0 and 1,000. So our output range is 1,000. So if we're 75% of our way along our input range, we should be 75% of our way along our output range. And if our output range is 1,000, we would do 0.75 times 1,000 would be 750. And then, so that's how far we are away from the output minimum, but we still have to add our output minimum at the end to shift it over. So yeah, take a look at it, think about it for a while. It should help a lot if you think about this dividing by this as being the percentage of the way x is from in min to in max. And then this is what that percentage should be transferred to. So 75% of what? Is it 75% of 1,000 if this range is 1,000? Is it 75% of 100 if this range is 100? And then we got to adjust depending on, are we starting at 0 or are we starting at 500 or whatever. Anyway, so that is the function. I hope this made some sense. Thanks for listening.